Donald Barack, I think I've come up with something.
Listen, Joe, we get that you think and see things.
No, not that. Look, these 3 blocks of code are different, but end up achieving the same goals, right?
You mean they are logically equivalent?
Yes, that. They are logically equivalent. They aren't functionally equivalent, though. You can tell just by looking. Block 1 doesn't take in any parameters, but still reads from and writes to the variable n.
So you're saying by that logic, block 2 passes a pointer to read from and writes to that address? That's obvious.
Yes, it is obvious, Donald, but that's not the point.
Block 3 takes in the value itself as a parameter and returns a new output. What are you getting at here, Joe?
When you account for how they are called, they have the ability to all do the same thing. So I wondered what would happen if we abstracted away the details of how an input is read and an output is written.
What do you mean abstract away the details of inputs and outputs?
I mean, not consider how an input is read or how an output is written. All that matters are that they are read and that they are written.
That's an interesting idea. Why do you find this useful, though?
Hold on, Barack. I think I see where he's going with this. If you remove the implementation details, you are left with just inputs and outputs. Because this seems to also account for any kind of external read, it should also abstract away the idea of side effects, since those are just reads and writes to external addresses. This means all blocks of code could be treated as pure mappings of inputs to outputs without exception.
Oh, you make a great point, actually. Joe, is this where you were trying to go with this?
I hadn't thought of it that way. I just knew that by abstracting away the implementation details, I could write all 3 blocks as the same thing. With that context, though, I clearly see how I can write this as a function that maps inputs to outputs. I wanted to call these abstracted versions transforms.
Transforms, that makes sense. They transform their inputs into their outputs. If we want to represent these mathematically, we need to know what exactly is being mapped. You said that the only things that matter are what's being read and written to, right? That sounds like a set of variables mapped to a set of variables.
You can only know the variables once you call the block of code, though. Without that, you don't know where return values are going, meaning they would have to be left anonymous.
Right. If we don't consider everywhere they are called, we are left with a more general definition of each transform. We may still want to convey the types of each input and output if possible. Even if they are anonymous, we have some way to convey information about them. I'm going to use Greek letters for anonymous variables for now.
So we can't use a set because we may just map 2 ints to a float. A multiset should cover that, though. So a transform maps multisets of inputs to multisets of outputs.
That works for me, thanks, Barack. Now that I can actually write these out with proper notation, I've realized that this is essentially an intermediate form. I could very easily translate a block of code to this transform, then translate it to a different block of code with the same transform.
Whoa there, Joe. I think you're getting dangerously useful right now.
Huh?
You know, language learning models like GPT, right? They can use transforms to rewrite your code for you. Though now that brings up a different idea. How do you restrict what inputs and outputs are? The way it is now, we can't know if it is accessed from a lower scope, accessed via pointer, or passed as a parameter. What if I want to restrict certain inputs to one of these, and similarly for outputs?
Donald, you can easily convey the idea with some extra notation. I'll use a left arrow for parameter or return, up arrow for higher scope, and right arrow for via pointer. Lucky for you, GPT can type these out, so it is also capable of restricting its transforms. Not all languages have pointers, though. That means these arrows only work for languages like C.
Yeah, if you tried to use this for C++, you'd still get ambiguous cases, or if you tried an APL, it just wouldn't make sense. For APL, you could just name your inputs alpha and omega under the assumption they are always passed in as a parameter. The single output is always returned as well.
Joe, when did you learn about APL?
Sometime in 1968, I believe Barack was about 7 years old at the time.
And why would you know that off the top of your head?
Joe, I see an issue here. Imagine I have a block of code that has one parameter, a record with fields A, B, and C. Let's assume it only uses A and C. C is a list of some kind. If I translate this to another language that does support the same kind of accesses, but has differing types or implementations of these lists, this doesn't work anymore.
I believe you just count the fields it accesses as the inputs instead, and either treat the list as an input or every element in the list as an input, whichever is most convenient and preserves the necessary properties for translation.
That checks out, and I realized something pretty neat as well. Since transforms are just functions that map inputs to outputs, they share all the same properties as functions, like the ability to be decomposed into subfunctions that you chain together, like the square root of e to the x. That can be broken down into e to the x and a square root. You can do the same for transforms as well, which makes perfect sense.
Brilliant.
Brilliant. Nice catch, Barack. It might be useful to give certain categories of indivisible transforms names. Taking some inspiration from a book I read last week called Data-Oriented Design by Richard Fabian, I suggest 3 categories. Filters take inputs and output a subset of them. Mutations take inputs and output mutated versions of them. And lastly, emissions, which take in inputs to seed the creation of outputs.
I read that book a few months ago, too. If you have emissions, wouldn't you also want something like sinks, too?
If you think about it, the idea of a sink makes no sense when you consider every external read as an input and every external write as an output. If there are no reads or writes, the block of code is useless and probably shouldn't exist anyways.
Joe, I believe you did indeed come up with something. This is a very objective way to determine if 2 blocks of code are logically the same. Nice work.
These seem a lot more useful and give us names for common patterns. Commonly, you see filters to mutations and mutations to filters. I think Rust makes this pattern very easy to visualize with its chainable filter and map methods.
Have fun with that. I'm getting back to my simple procedural code base. You and all of your abstract thoughts, I blame object orientation for corrupting you. It's the memory that counts.
If I take my class code and your procedural code and convert them to their transforms, they are the same thing. Donald, you are writing procedural object-oriented code, you hypocrite.
I will find you.
We literally just went over this.